Hey, there's Mr. Alexander, and I want to talk to you about a few things we did in class on March 12th and March 13th. The first thing we did was some word problems that involved solving rational equations. For instance here, the reciprocal of the product of two consecutive integers is 1 over 42. Find the two integers. What I always like to do is I like to define my variables before I do anything. So in this case, x is the first integer. Of course, an integer is just like a whole number, 1, 2, 3, 4, but it's also could be 0 or -1. Now we're talking about consecutive integers, so that means integers that are right next door to each other. So if I've got one integer, the one consecutive to it is x plus 1. So that'd be my second integer. And I know that the product of these things, the reciprocal of the product, is 1 over 42. So first off, the product is just x plus 1 times x. The product means multiplication. But the reciprocal of that is 1 over x times x plus 1. I know all of that equals 1 over 42. So what I'm trying to do is find the two integers. I'm trying to find x and x plus 1. And I think the easiest way to do this is by cross multiplication. So x times x plus 1 times 1, of course, is just x times x plus 1. And 1 times 42 is just 42. I'm going to go ahead and distribute that x to get x squared plus x, and that's going to be a quadratic. So while I'm at it, to solve a quadratic, I need to have a 0 on one of these two sides. So I'm going to go ahead and subtract that 42 over to this side of the equation so that I can have a 0 over there. Now, I need to solve this thing. And you've got some options. You can factor, you can use the quadratic formula. But I prefer to use the quadratic formula in this case. So what I'm going to do is two numbers that multiply to -42 but add to +1. Well, that's just x plus 7, x minus 6 equals 0. And then you'll want to set each of these equal to 0. So that means that x equals -7 and +6. What does that mean? Well, you need to go, that's why I like to define my variables at the very beginning. So x is the first integer. So I've got two options here. If -7 is the first integer, then the second one, x plus 1, is -6. So that's one of the two solutions, because I'm trying to find the two integers. So it could be -7, -6. And the other option is if x is 6, then x plus 1 is 7. So these are the two possible integer combinations, -6 and -7, or +6 and +7. Another kind of problem we did was this one. Cedric can refinish the floor in 8 hours. Carolyn can refinish the floor in 6 hours. How long will it take them working together to refinish the floor? And I've set up a little hint for you here. So if he can finish the floor in 8 hours, then in 1 hour, he can do 1/8 of the floor. In 2 hours, he can do 2/8 of the floor. And in t hours, he can do t over 8 of the floor. And Carolyn can do the whole thing in 6 hours, so that means she can do 1/6 of the floor in 1 hour, 2/6 of the floor in 2 hours, and t over 6 of the floor in t hours. So the way I like to think about this is, to get the whole floor, you're going to do Cedric's part plus Carolyn's part, and that whole thing is going to equal the whole job, the whole floor. So Cedric's part, we've already said, is t over 8. And Carolyn's part is t over 6. So the whole thing, 100%, well, that's just going to equal 1. So now I've got a rational that I just need to solve here. And what I'd like to do to solve these is just multiply the whole thing on both sides by the lowest common denominator. And of course, the lowest common denominator between 8 and 6 is 24. So whatever you do on one side, you got to do the other. So 24t divided by 8. 24 divided by 8 is simply 3t. 24 divided by 6 is going to be 4t. And that whole thing equals 24. 3t plus 4t is 7t equals 24. And of course the last step is t equals 24 over 7, which is approximately 3.43, and the units here is hours. That's how long it's going to take them to do the whole floor together. 3.43 hours. And the last kind of problem that we did, and it's probably the most challenging, is this one. Rate times time equals distance. The current in the lazy river moves at a rate of 4 miles per hour. Monica's dinghy motors 6 miles upstream in the same time it takes the motor 12 miles downstream. What is the speed of the dinghy in still water? So let's start by defining our variable x. And that's going to be Monica's dinghy speed. And I like to think about this in terms of a table. I'm just going to make myself a little 4x3 table here. So I know that rate times time equals distance. And I've got two scenarios here. I've got the upstream, which is against the current, and the downstream, that's with the current. So she's going to go slower upstream than she would downstream. I know that the rate she's going, it says the current in the lazy river moves at a rate of 4 miles per hour. So when she's going upstream, she's getting slowed down by 4 miles per hour because she's fighting against that 4 miles per hour. If she's going downstream, whatever her speed is going to be 4 miles per hour faster because she's going with the water. I also know the distance. Monica's motor device motors 6 miles upstream in the same time that it takes her to motor 12 miles downstream. So the distance here is just 6 upstream and 12 downstream. Now to get the time, this is where we need to realize that we can use this formula. Rate times time equals distance. Well, if you solve for t here, then t equals d divided by r. Distance divided by the rate. And so I know my distance, I know my rate. So the distance, 6, divided by the rate, x minus 4. And then the distance here, 12 over x plus 4. Now the last step's the big one. You need to realize what it says right here, where it says that she can go 6 miles upstream in the same time it takes her to go 12 miles downstream. That means that this t, that time, is the same for both equations. So that means these two times are equal. So I'm going to set them equal to each other. 6 over x minus 4 equals 12 over x plus 4. And hopefully you can see that this is just a rational equation that you can cross multiply and solve. So I'm going to cross multiply and get 6 times x plus 4 equals 12 times x minus 4. Which is 6x plus 24 equals 12x minus 48. Solve for x, so if we subtract the 12x and subtract the 24, we've got I'm sorry, let's subtract the 6x and add the 48 to both sides. That's going to give me 72 equals 6x, or 12 equals x. Now, don't forget your units here. That's not just 12, that's 12 miles per hour. And that's how you solve that problem. Now, that's the three kinds of problems that you're going to deal with these rationals. The three kinds of word problems. But I want to show you one other thing very briefly, and that's about discontinuities. And what you need to know about discontinuities is right here. I've got it written down already. A rational function will have a discontinuity whenever the function is undefined, i.e., at every value of x that makes the denominator, the bottom of the fraction, equal 0. Now, a couple of key things you need to remember here. If a factor cancels out of the denominator, there will be a whole at its 0. If the factor does not cancel out, meaning it's still in the denominator, there will be a vertical asymptote at the 0. So let me show you what that means. Look at this guy right here. I've got x minus 3 times x plus 4 and divided by x plus 2. So I'm going to list two things. I'm going to list the vertical asymptotes and the wholes. Now, I see one thing in the denominator here. It's x equals 2. So I need to take that whole thing and set it equal to 0. And when I do that, x plus 2 equals 0. Subtract 2, you get x equals negative 2. So I have a vertical asymptote at x equals negative 2. Now, I didn't cancel anything, so there are no wholes. Nothing. Let's look at b here. X plus 6 times x plus 4, all divided by x plus 4. Hopefully you recognize we can just cancel out those x plus 4s, which leaves me with y equals x plus 6. There's nothing in the denominator besides a 1. And when that's the case, there are no vertical asymptotes. But we do have a whole. And it's at wherever the value of x that makes this a 0 is. So it's at x equals negative 4. When you set that equal to 0, solve, you get x equals negative 4. So we've got one where there's vertical asymptote, no holes, and where we've got a no vertical asymptote, but a hole. So here we'll probably have both. And when you can, you should start by factoring. So on top, I'm going to take out the greatest common factor of a 3, and be left with x minus 5. And then we need to factor this guy, and that's just 2x plus 1 times x minus 5. And from this point, we can see that we can cancel out these x minus 5s. Let's start with the vertical asymptote. I'm going to have 1 because I have something in the denominator, and what I need to do to figure out where that vertical asymptote is, I'm just going to set 2x plus 1 equal to 0. You subtract 1, divide by 2, that's x equals negative 1 over 2. So I've got a vertical asymptote at x equals negative 1/2, and I have a hole at the value of x that I cancel out, so at x equals positive 5. So remember, whatever's left in the denominator gives you your vertical asymptote. Whatever you cancel out gives you your holes. Thanks for watching. Hope this was helpful.